Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy, Subject Code 22626, Unit 3, Electric Drives and Elevators. Standard rating as per IS, Indian Standard, is the three. First is the continuous rating. A motor is capable of giving output continuously without exceeding the temperature rise. It can also give 2.5% overload for 2 hours. And second is the continuous maximum rating. Similar to the above, without any overload capacity, it is used for motors of size larger than 2.5 HP per RPM. Short time rating, it is the output that a motor can give for a specified short time, say 1/2 hour or 1/4 hour, without exceeding the specified temperature rise. Next is the load cycle. The motor has to operate for different types of loads. The characteristics of each load are different and it is studied under the load cycle. So first is the continuous load or continuous rating. As the name suggests, the load does not change. It is constant for a long duration of time. The motor should be able to supply power to the load without exceeding the temperature rise. Next is the short time load. For short time rating, the load is present in the on and off from it present between certain intervals. The load is present at a regular intervals. In between the intervals, motor is off. The motor is loaded during on period and its temperature rise take place. The off period is sufficient to cool the motor to the ambient temperature. Motor used for log gates bridges. Next is the intermittent load or intermittent rating. The frequency of occurrence of the load is more. In this that way, similar to the previous type, but the law of period of the motor is shorter than the previous case, and hence off period is not sufficient to cool the motor to the ambient temperature. So the temperature continuously rises with the time. Example, motors used for cranes, lifts, rolling mills, metal process industry. So the motor cannot cool down to the ambient temperature. Next is the continuous operation with the short time load. In continuous operation with the short time load, there is no off time, but during short time load, motor runs at no load condition. So, motor runs continuously. The heat produced by motor is carried away by proper ventilation arrangement. Example, motor used to drive the generator in Ward-Leonard system. So, motor off time is more, that is no load period is more. The motor is kept on during no load condition. So the sorry. So the next is continuous rating with the intermittent load. Similar to the previous case, but frequency of the load occurrence is more and the temperature of the motor increases. Since no load period is small, the motor cannot cool down to the ambient temperature. This is the estimation of size rating of the motor. The applications such as air compressor, blowers, pumps, fans come under constant load category. Choice of motor for this type of load is simple. The motor chosen should not be too small, otherwise it will be overloaded. The motor should not be big size, otherwise it will operate much below its rated capacity, giving the poor performance, that is poor efficiency and power factor. So optimum size of the motor has to be selected. For the above applications, there is no possibility of the overloading because load pattern is constant. So a motor with the continuous maximum rating can be selected. Such motor will be smaller in size and cheaper in cost and can operate at high temperature, that is 55 degrees Celsius. The size or rating of the motor can be determined as follow, that is output power of motor 2 pi nt divided by 60, where n is the speed in rpm, t is the torque in Newton meter. So here is the diagram for motor supplying power to the load. So motor and load and the transmitting device. Considering the efficiency of the driven load and transmitting device by means of factor efficiency, that efficiency equal efficiency of driven load into efficiency of transmitting device. So power in kilowatt equal to 2 pi nt divided by 60 into 1 by efficiency into 1 by 1000. The value of efficiency is obtained by experience. The above expression is for rotary motion of motor, and for linear motion of motor, following expression is used. P equals to F into 9.81 into V divided by efficiency into 1 divided by 100 kilowatt, where F equal to force caused by load in kg, V equal to linear velocity of load in meter second. So the example of the linear load is hoist or lift. So expression can be used with the modification for hoist. So the expression becomes, it is given by P equal to Fv divided by 2 into 102 eta kilowatt, where V equal to 0.5 to 1.5 meter per second for passenger lifts. As the case of pumps, the rating of water is given by P equal to Q into rho into H divided by 102 efficiency kilowatt, where Q equals to delivery of the pump in meter cube second per second. Rho is the density of the liquid in the kg per meter cube. H equal to gross head in meter. The rating of the fan motor is given by P equals to QH divided by 102 eta kilowatt, where Q equal to volume of the air or gas in the meter cube and H equals to pressure in mm of water or in kg per meter square. Other methods of finding the rating of the motor for continuous duty are as follows. That first is the equivalent current method. In this method, an assumption is made that actual variable current is equal to the equivalent current, i.e., this I produce some losses as produced by the actual variable current, i.e. equal to I1 square into T1 plus I2 square into T2, then till the n number, divide by T1 plus T2 plus Tn. Second method is the root mean torque method or equivalent torque method. The motor current is proportional to the torque and the heating is proportional to the current square. Therefore, the relation is heating is proportional to the torque square. Next method is the case of short time and intermittent load. The load or torque does not remain same, so equivalent torque is considered. So here is the graphical representation. So the equivalent torque T equivalent produce same heating as produced by T1 plus T2 plus T3 Tn. So the formula is this. And the third method is the heating curve method. Heating time curve method. The final temperature attained by motor is proportional to the loss or I square or load square. So theta F equal to permissible temperature rise with the continuous load of P watt. Theta dash F equal to maximum temperature rise that take place with the short time load of P dash watt. So we can write losses of at load of P watt proportional to the P. Losses at a load of P dash watt is proportional to the P dash, since the temperature rise is proportional to the load square and it is given by this. So now we'll move to the numericals. So here is the draw the curve and estimate the suitable HP of the motor having the following duty cycle. So the duty cycle is given here, and now the data is given that rising the load from 200 to 400 HP, that is 4 minute time, and uniform load of 300 HP 2 minute, and then regenerative braking from 50 to 0 1 minute and idle for 1 minute. So in this the H formula is 1 by 3 H1 square plus H1 into H2 plus H2 square into T1 the time period, then H square T square, then plus 1 by 3 H4 square into T3. Then we have to fill the formula in this equation and divide by T, that is the total time. So by finding the answer, we get answer, that is the 263 HP. So here we simply put the formula of the slope. So the slope formula we have put in from two different heights, and in this formula we have put the values of for this HPs and the time required, and the total time is calculated 8, that is 4 plus 2 plus 1 plus 1, that is the total time is carried out. So according to the question, we have found the total HP, okay, that is the 263 HP. Also we have drawn the graph, the graphical representation between the HP and the time as given in the question. So how this we can solve the sums numericals from this chapter by solving we know the time, and then we have to plot the graphical representation. So in the question it is given that rising from 200 to 400. So we have raised the slope from 200 HP till the 400 HP, and the time span was the 4 minutes. So like this we have solved it. Thank you.